Hello YouTube. This is the second video I'm doing on the basics of blade geometry, and this one is going to cover grinds. There are four basic grinds found on knives, which are the flat grind, the convex grind, the hollow grind, and the chisel grind. And there are some variations to those which I'll be discussing as I get to them. What grind means is how the blade gets from the thickest part at the spine down to the narrowest part at the cutting edge. And most blades have a secondary bevel at the cutting edge, but generally speaking that is not considered to be part of the grind. And there are some exceptions to that which I'll also be discussing. Now, the first and most common grind is the flat grind. And on the flat grind, the edges taper in from the spine down to the cutting edge equally on both sides of the knife with no kind of curve. And a flat grind that starts at the very top of the spine is a full flat grind. There's a very good example of that on Cold Steel's Western Hunter. You can see the grind starts at the very top of the spine and goes straight down to the cutting edge on both sides with no curve. The Victorinox Swiss Army knife is a much smaller blade, but again the grind is the same. It starts at the top of the spine and goes straight down to the cutting edge with no curve. And full flat grinds are very good cutters because the blade basically acts as a wedge and pries apart whatever material it's cutting through for the full depth of the blade, which definitely enhances the cutting ability of the knife. There are a couple of variations to the flat grind, which are the high flat grind and the saber grind. And a high flat grind simply means that the spine actually extends a short way down into the blade before the start of the grind, as you can see on this Buck 301V. And if the spine extends down further into the blade, say halfway or so, that is considered to be a saber grind, as you can see on the K-bar. And most of the knives in my house are saber grinds, including the kitchen knives, which you can see on this one. The spine actually extends down a little over halfway of the depth of the blade before the start of the grind. Now, because these knives have more of the spine extending down into the blade, on equal quality knives, a saber grind will be a stronger knife than a full flat grind. And that means that a heavy duty outdoor knife like a K-bar would be very, very good for prying when you're out doing bushcraft. And even a kitchen knife is stronger because of that spine, and if you were piercing something very solid with it, say a pumpkin, watermelon, pineapple, that spine keeps the rigidity of the blade, and so it won't flex or bend on you. There is another variation of the flat grind which is known as the Scandinavian grind, or the Scandi grind, and that grind does not actually have a secondary bevel. So a Scandi grind actually does go from the spine right down to a very acute cutting edge. And those knives can get incredibly sharp. And they're also fairly easy to maintain because if you're sharpening them, you don't have to worry about maintaining the angle of the bevel. And so you can just lay it on a stone and quickly restore your edge. The downside to a Scandinavian grind, though, is that those blades are so acute, that edge is so sharp, that sometimes they're prone to roll very easily. But it's a good trade-off if you need a very, very sharp knife. Now, I don't have any Scandinavian grinds here, but it's definitely a blade that needs to be mentioned. The flat grinds are very easy to sharpen with either stones or sharpening systems, and they're so easy to sharpen that a lot of people actually modify them and put a double bevel on them. Now, the production edge of most factory knives comes at somewhere between 22 to 25 degrees per side, which is just not sharp enough for some people. So what they'll do is they'll reprofile their edge and cut that bevel down to 15 or 17 degrees, and then they'll come back with 20 degrees and put an edge on the edge, and your original bevel is now called a relief edge, and the new cutting edge is a micro bevel, and they are small. I don't know if I can get this one to show up on this knife. It's less than ½ millimeter thick, but we'll try. Put the light on it. So we go from the grind to... that's not working. So we can go from the grind to the relief edge, and then maybe I can get that to show up. But anyway, the reason they put that secondary bevel on there is to return the blade to about 20 degrees, which is a bit more obtuse than that 17 or 15 degree angle, and that helps in edge retention. The next grind is the convex grind, and the convex grind actually bows away from the cutting edge, which makes the knife a very good cutter. Like a boat hull that displaces water, the convex edge actually pushes the material that is cutting through away from the sides of the knife, and that decreases friction, which enhances the cutting ability of the knife. The disadvantage of a convex edge is that it has to be sharpened on a belt, and that is a skill set all in itself. If you don't know what you're doing, you can destroy a knife blade in a hurry with a belt. Fortunately today, almost anybody can sharpen on a belt thanks to the Worksharp knife and tool sharpener. And I did a video on how well this worked to put a convex edge on this Bowie machete. And you can see that it's been used since then, and it's not nearly bright and shiny as it was on that other video. But this knife has been an excellent cutter for me since I did that to it. Now the Worksharp does have some quirks, and even if you follow their directions and do it exactly like they show you on their videos, you can still destroy a knife blade on the Worksharp knife and tool sharpener. So I intend to do a video on how to avoid some of the mistakes that caused that to happen, and if you plan to get one of those, watch out for that. It'd be worth watching. The next grind is the hollow grind, and the hollow grind actually bows in from the spine down to the cutting edge, and that is another excellent cutter because it allows for a very narrow blade width at the grind, but it still maintains the strength and rigidity of the knife because it still has a fairly thick spine. There's a good example here on the Cold Steel Coben. You can see that blade has a very distinct curve to it on both sides as it curves down from the spine to the cutting edge. Here's another version on the Bird Flight. I can get the light to shine on that right. You can definitely see the curve in that blade also. Now most hollow grinds have a secondary bevel at the cutting edge, and the problem with those is that if you were to chip that edge, or if you just wore it out from years and years of use and resharpening, you'd have to get the knife professionally resharpened, because a hollow grind actually requires grinding wheels on machinery on both sides of the blade to sharpen it as it's pulled through, and that is not something you could do. Well, it's certainly not something I could do at home. And finally we have the chisel grind, and as the name implies, on these blades all the grind is done on one side just like a chisel. So basically the blade comes down perpendicular from the spine to the cutting edge on one side, and all the grind is done on the other side. Now, because there's only one angle on these blades as opposed to one on either side like these other grinds, chisel grinds can get incredibly sharp. Now here's a good example of it on the Gigan Guardian. You can see this side is completely flat, and all the grind is done on this side. Now the complaint that people have with chisel grinds though is that the knife tends to push away from the bevel side and towards the flat side when you're cutting, and so they complain that it's sometimes hard to cut a straight line with a chisel grind. But chisel grinds make excellent fillet knives because they do get so sharp, and a lot of Japanese sushi knives are chisel grinds, and those things are incredibly sharp. And here is another version of the chisel grind on the Okapi 907E. Again, you can see this side is completely flat, perpendicular to the blade, and all the grind is done on this side. So that covers the grinds. I hope you found some good information in this video, and again, as always, thanks for watching.